Hello students. Our next topic is freight train. Freight train means it is a cargo train with multiple masses. So we consider the three compartments of a cargo train or the freight train. Okay. So here we will be dealing with materials having multiple masses. So consider this is the three compartments of the freight train. Each has a mass m and it is pulled by a force F along this direction. This is the direction of the acceleration. So three freight cars, each of mass m, are pulled with force F by a locomotive. Okay. Friction, here we take it as 0. Friction is negligible. We have to find the forces on each car. So we have to find out, the problem here is to find the force on each car. Okay. Now you have seen that the cars are joined together with each other. Okay, the cars are joined and are thus constrained to have the same acceleration. So each has a same acceleration a, and because of the total mass is 3m, each has a mass m, so the total mass is m plus m, that is 3m. Therefore their acceleration a is equal to F by 3m. So F is the force with which the locomotive drives, or it pulls the train, and 3m is the total mass. Okay, so the acceleration, which is the same for all the compartments, A is equal to F by 3m. Now consider the third car. Okay, on the third car, you can see the forces. This is the weight of the car toward downwards, and N is the normal reaction in the upward direction, and A is the acceleration, and F3. So this is the force diagram, and W is the weight, and N is the upward force exerted by the track, which will be equivalent to the weight of the car. And F3 is the force exerted on car 3 by car 2. Car 2 is in front of car 3. Therefore, it is F3 is the force exerted on car 3 by car 2. Okay. Since the vertical acceleration is 0, we have N is equal to W. And the horizontal equation of motion is F3 is equal to MA. Okay, F equal to MA, or here there is only one force acting on this mass F3, which is equal to MA. M is the mass of the object of the car, M into A is common for all, so that is F by 3M. Or when we cancel M, we get the value of F, the force with which the car 3, the force exerted on car 3 by car 2 is F by 3. Okay. Now take the second car. Here let us consider the middle car. The vertical forces are as before, we omit them, they will be equal. There is no vertical motion for that, for any one of them. So we ignore them. Okay. Now what is F3 dash? F3 dash is the force exerted by the last car, that is the third car, which will be equal to the force exerted by the car 2, which is F3, which we have dealt earlier. So F3 dash is the force exerted by the last car, and F2 is the force exerted by the car 1 in the front direction. So this is the middle car. So F3 dash along this direction and F2 along this direction. Now the equation of motion will be F2 minus F3 dash is equal to MA. So the difference, the net force will be F2 minus F3 dash equal to MA. Now by Newton's third law, we know that F3 dash, which will be equal and opposite to F3. Okay. Since F3 is, the value of F3 is F by 3. Therefore F dash is also equal to F by 3. Now since A is equal to F by 3m, F2 is equal to MA is, so from this equation F2 is equal to MA plus F3 dash. Okay. F2 is equal to MA plus F3 dash. So in that equation, when we substitute the values of A as well as f dash 3, f2 is equal to m into f by 3m plus f by 3, that is equal to 2f by 3. Okay, f2 is equal to 2f by 3. Now the first car, the horizontal forces on the first car are F, which is the force from outside, F to the right, and we have F2 dash towards the left side. So F2 dash is equal to F2, that is equal to 2F by 3 to the left direction. This is the value of F2 dash in the left direction. Therefore, each car experiences a net force F by 3 to the right. So the net force F is divided among the 3 cars, for which each car experiences a net force of F by 3 to the right. Okay. Now here is a more general way to look at the problem. Here consider a string of n cars, each of mass m, pulled by a force F. So we have starting from 1, 2, etc. up to n cars. Each has a mass m and it is pulled by a force F. Okay. Now the acceleration A is equal to F by nm. Now to find the force Fn pulling the last n cars, note that Fn must give the mass nm and acceleration f by nm. Hence, Fn is equal to nm into f by nm. This is A. Okay. So you get n by n. When cancelling m, you get n by n Fn. Fn is the force pulling the last n cars. Fn is equal to n by n f. Okay. The force by which one car pulls another, in other words, the force between the cars is proportional to the number of cars pulled. Force between the cars is proportional to the number of cars that is pulled. Okay.